All right. Hi, everybody. So let's do a little bit of review here for 14. Let's do a little bit of review for 14, and then maybe we'll start 15 depending on how productive we're being with this. Sounds good?
Yeah.
Yeah, you didn't have a choice.
Okay.
All right. So let's say we ask you to find the domain for this. So Joey says set the denominator equal to 0. So you can solve that by factoring. Hi. Joey, this is your get out of jail free card. You're welcome. Okay, so the two solutions here are 2 and -2. Okay, is that it?
No.
So now we need to write our domain with intervals, right? So how do we write the intervals?
Does it matter which one goes first?
Typically go smallest to biggest, but you missed one. There's still more. Yeah, you also need -2 to 2 in here. So it should cover everything except for the place where the denominator is 0. But that's it. Cool? Let's see what's next on there. Vertical asymptotes. Okay? So let's just do that for the same thing. So I'm just going to use that same rational function there. What do we have to do here? Eventually, but we need to check something first. I have to check if I can reduce, right? So it needs to be the reduced denominator set equal to 0. So to reduce this fraction, if it can be reduced, what do I need to do? Factor the numerator and the denominator. Someone other than Joey, how does the numerator factor?
X plus x minus 3 to x minus 2.
There you go. You have to multiply to get -6, or sorry, +6, and then add to give -5.
Yeah, what do you do with the 5?
So multiplies to give +6 and adds to get -5.
Wait, for the bottom, where did the x minus 2 and x plus 4 come
Sorry, it should have been a 2 there.
from? Oh,
My apologies.
wait, reiterate that?
Okay. So we need two numbers that multiply to give us +6.
Yeah.
So there's lots of those, right? There could be 1 and 6, -1 and -6, 2 and 3, -2 and -3. To which one of those pairs should I pick? The one that adds to -5 also.
Okay, got it.
Okay? So that's like ideally at the end of Algebra 1, you're able to do these effectively quickly. We're now senior pre-calculus senior, so we should be able to do this still. All right, so we did all the factoring. How do I do the reducing?
Get rid of the
Get rid of 2 plus 2 and then negative.
The x minus 2's can go, right? So hold on a second, because right now we're asking for vertical asymptotes. So we've reduced the fraction, right? Now I can take the reduced denominator and set that equal to 0. Right? So if I wanted a discontinuities and it doesn't ask me which type, it's just the entire denominator set equal to 0, just like the domain. If I want the removable discontinuity, so that's going to be the thing that we completely reduce from the denominator. I set that equal to 0 and solve. But the removable discontinuity is a point. It's not a line, like a vertical asymptote's a vertical line, so it's x equals. A removable discontinuity is a point. It's a hole somewhere on our graph. So to find that value, the y-coordinate, I'm going to plug that x value into my reduced problem. So my removable discontinuity would be 2 comma negative 1/4. Ava.
So just to make sure, for removal discontinuity, but
You just say the RD.
the RD, you do x minus 2, so that could.
I take the factors that are completely reduced from the denominator and set them equal to 0. If there's 5 of them, I would have 5 things. Now, you wouldn't see that on a test. That's like way too much. But anything that's completely reduced from the denominator, we set equal to 0.
So you wouldn't have to do x minus 2, you could just do x plus 2, or x.
For removal discontinuity from the beginning.
Like, for the RD.
So the removal discontinuity is the pieces that are completely reduced from the denominator. So what piece was there to start with and is no longer there? The x minus 2. I set that equal to 0. I solve. That x then I plug into the reduced problem. So I plug 2 into x minus 3 over x plus 2. And that'll give me the y-coordinate to go with the x. Because the removable discontinuity is a point. It's a location. It's a hole. It's not a line. Yeah. Everybody feel okay there? So that's the first 3 things. So the next one are the zeros. I'm just going to keep using this same problem. Oops. Just FYI here, 1 second, real quick. What happens if, like, say, I can't factor this? No, man, just tells me there's no removable discontinuities. I don't have to do anything more. If I can't factor it, I can't factor it. That's fine. That can happen, right? That makes life easier as far as, like, domains, removal discontinuity, vertical asymptote. I'd prefer the numerator not be factorable because it just means that nothing weird is going to happen. I can just set denominator equal to 0 and go. You know what I mean? Which I think is what happened on the quiz, right?
Yeah.
All right. Zeros, how do I find the zeros? Close. Reduced numerator equal to 0. So again, in general, unless you're looking for a domain, the first thing you'd want to do is see if you can reduce. Now, you might not be able to reduce, and that's okay. That's it. Everybody cool? Okay.
Wait, so will the y always be 0 then for those?
For the zeros?
Yeah.
Yes.
Okay.
Because where does the 0 occur? On the x-axis. Any point on the x-axis has y-coordinate of 0. Because you've gone 0 up, right, when you plotted the point. So yes, always. Y-intercept. Oh, goodness gracious, guys. How do we do that? Yeah, we just plug in 0 for x. Could anything screwy ever happen on that? Now in this one, everything goes fine, right? Could anything weird ever happen? The only thing weird that could happen on this is if there was a discontinuity at 0, right? If you had a vertical asymptote there, maybe you get undefined, so no y-intercept would exist. Or you could get a removable discontinuity at 0. Again, no y-intercept exists then. Now, would I put that on the test? No, but again, some of us, have plans of taking ACTs or whatever in the future, and maybe that's a question, right? Because it's a relatively easy question, but it really focuses on the vocab there. All right. What else do we got here? Okay. Example of a rational function with the given end behavior asymptote. Okay. Let's say that our asymptote is y equals 0. What does this rational function got to look like if it has the horizontal asymptote of y equals 0? The degree of the numerator has to be less than the degree of the denominator. Does anything else matter? Just has to be a rational function that has to meet that criteria. That's it. So, Mr. Kulik, could I do like 1 over x? Sure. Could I do x minus or x plus 3 over x squared minus 5? Yeah. Does it matter to me? No. Is all I'm going to look for the degrees? You betcha. Everybody's all right? What if instead it was y equals negative 1/4? If it's a constant that's non-zero, I know the degree of the numerator has to equal the degree of the denominator. And then it's going to be the leading coefficient of the numerator over the leading coefficient of the denominator. So I need then a rational function where the leading coefficient in the numerator is what should it be? 1 or negative 1 would be the likely choices. So let's just do x plus 3. Since I picked positive 1 for the numerator, what does the leading coefficient in the denominator have to be? Negative 4. Right? And what does the degree in the denominator have to be? 1, because the degree in the numerator was 1. And then I can do whatever I want after. The numbers afterwards don't matter. So all I'm looking for is that the degrees matched and then the leading coefficients match. That's all I'm looking for. That's all you have to worry about. Everybody okay with how to do that? What if it was a slant asymptote? Right. Yeah, we should say so what that tells me is that the numerator divided by the denominator should equal x plus 1 plus some r over the denominator. Well, I'm just showing you how to do this, right? So what I'm going to do is I'm going to pick a denominator. Let's pick the smallest denominator we can pick. How about x? Because if it's a constant, it's not a rational function anymore. It's just like a polynomial, right? So we'll have everybody's good? Now I'm going to pick a value for r. Should pick something non-zero, or else this will just reduce to a straight line, and we don't want that. So what's going to be the easiest number to pick for r? Yeah. Again, and we can just choose because it doesn't want us to find a specific one. It just, any old one will work, right? So if I add that up, I should get an answer. To add those two, what do I need to have? Common denominator. What would the common denominator be? X. So I just like multiply this one by x over x. There's my answer. I wouldn't ask you to do that in the test. It's too involved. But that's the idea. Not that it's impossible to do, but like that's kind of tricky, right? Okay. What letter, what number are we on here? 7. All right. So let's say I give you this picture and I ask you to write the end behaviors using limit notations. How many limits are we going to need to write here? 6. Why 6? 1 for each arrow, right? Everybody's good with that? 1 for each end of the graph. 1, 2, 3, 4, 5, 6 of them. So just for organizational purposes, I'm going to label them A, B, C, D, E, F. Everybody cool? All right. So let's just kind of bang these out one at a time. So A, limit x approaches something, f of x equals something. Right? Every limit kind of starts looking like that. There's 2 things I have to fill in here and here. What should the x be approaching? Negative infinity, right? Because it's the left arrow, it's pointing straight to the left. And what should the limit equal there? -2 should be the y coordinate that we're hovering at. Everybody feel good there? And then now which other one is going to be almost just like this one? F. The other one that's and the only difference there is that it will be positive infinity instead of negative infinity. You don't have to write the positive sign, although I always do. Everybody's good? All right. Now let's do B. All right. So you say positive infinity. Where's the positive go? Not the x. It goes over here because the arrow's pointing up, right? Up to positive infinity. But where is the x value for that arrow at? -3, right? But which side of -3 are we on? The left side of it or the right side of it? The left side, that's where the negatives live, so we'll put a little negative superscript. And that's how we designate that. And then C is the same thing, right? Except instead of being on the left side of -3, we're on the right side of -3. The positives live on the right, so we put a little positive superscript there. Let's just say that's the right side of -3.
I don't feel like, because for A, you did like, oh, X is negative. It looks like it's like the same thing for B, but it's pointing up.
Right, so the y coordinate is going to -infinity.
Oh, so,
That's what f of x is equal to. Like f of x is y.
B would be like X, which is, what, 1?
Yes, from which side though?
The left side.
Okay, so we need the negative in the superscript. And then what is the y coordinate doing? -infinity. And then E would be kind of the same thing, except instead of the left side of 1, we're talking about the right side of 1. But everything else would be the same. Does that feel okay?
Why is sometimes the, like, for A, the negative, the number, and then the infinity are flipped between A and B? Like, on the first line, infinity, the -2 is there. For B, the first line is.
So if we look at this and we think about it as a point, the x is the left and right direction. That arrow is pointing left to -infinity, but it's flat. It's not going anywhere, right? It's like horizontal. So the y is constant at -2. So this is like, if I think about this as like an xy, that's like the x and that's like the y. If I do the same thing over on B, and I think about this as like an x and a y, the x is at -3, but the y is pointing straight up to positive infinity. Does that?
Yeah.
So just think about them like xy coordinates. Like where's that arrow with an x and y coordinate? If the arrow is pointing either up or down or left or right, those get infinities. But if it's otherwise vertical or horizontal, then either the x or y would be a constant, right? Does that?
Yeah.
Okay. Again, like not hard to do. It's just like, how do I need to write this? Like the notation is the tricky part, and understanding like, how do I translate what I'm seeing to the symbols, right? But there's no like calculation to do. All right. So on the quiz, we had like we drew the graph, right? All right. So I think this is going to work. Excuse me if I make a boo-boo here and have to adjust something later. This is me trying to create something on the fly, imagining it in my head and then writing it down. And sometimes it's tough to hold all that information all at one time. All right, so we're told to draw a graph that meets all this criteria, right? Where do I want to start? Yeah, absolutely. First thing I want to do is get those asymptotes on there. So I have -2 and +2. And then I have y equals 3. Okay, what's next? Yeah, drawing the point stuff. So the zeros, I have one of them at -3, 0, and one at -1, 0. And the RD's at, oops, that shouldn't be 3. Let's make that 1, 2. So when I draw the RD, I have to make sure I'm using an open circle. The zeros are filled. The y-intercept would be filled. I guess I forgot to write that in there, but like, who gives a rip? It's fine. Everybody's good so far? Now, what I would do next is I would look at those end behaviors first. So this first one, I'm looking at the left side of -2 and the arrow's pointing down. Right? So while I know it has to go through like that, and it can't cross the asymptote, and that does indeed match what I'm seeing there. Everybody feel good? Now let's look at this one. I should be at +infinity. Ah, boogers. Let's make that one negative and this one positive then. We'll go with -infinity, so it has to be there. It's got to go through those. And if I look at the next one, it's +infinity, so it's going to go back up. If I look at the last one, it's +infinity. And then it can't cross or shouldn't cross the asymptote at the ends. So it's got to look like that, which again matches what I see there. So my advice is to look at the infinites, the ones where x is approaching infinity. Those will probably take care of themselves if you do the rest of it.
First one, how do you know it's not above like the X person that you can is that because like
So you're talking about this one?
no, the first one.
This one.
Yeah.
I was able to figure out, because I had to draw this part, I knew it had to be, it's got to follow 3. The only way I can't cross and come back, like, it just got to follow it. You know what I'm saying? So it almost didn't matter. Like those ends with the horizontal asymptote there, I don't really even need them.
Okay.
Does that feel okay? And I think the last two things were solvings and the inequality, right? Yeah. Is this feeling any better? Yeah, go ahead, dude. We're all right? All right. So I apologize in advance. This probably won't work out nicely. But I want to create something that's adequately complicated, that's let's do that. Okay. Let's say you have this solving problem. Yeah, first thing we want to do is factor, right? Because the method we're going to use to do these solvings is to clear the fraction. So how does x squared minus 1 factor? X plus 1, x minus 1. How does x squared plus 2x plus 1 factor? X plus 1, x plus 1, right? And the last one doesn't factor at all because it's clearly already just monic or whatever. All right, so what are we going to multiply both sides of this equation by? Close. Yeah, x plus 1. I'm going to write as x plus 1 squared instead of x plus 1, x plus 1. But that's either is fine. Okay. So when I multiply x plus 1 squared times x minus 1 to the first fraction, what am I left with? I have the x from the numerator and just an x plus 1. Everybody's cool? When I multiply it to the next fraction, I have the x plus 2 from the numerator, and the only thing left then is the x minus 1s because the x plus 1s cancel. When I multiply here, I get x plus 1 times x minus 1. Well, I still have the 1 from the numerator, but like, who cares? But just one of the x plus 1s cancel. Everybody good? Now I'm going to multiply everything out. Let's move everything onto one side. So if I subtract an x squared from both sides, those cancel out. If I add 1 to both sides, that's going to turn into a minus 1. So I have x squared plus 2x minus 1 equals 0. That's not going to factor, so what do I need to do? Quadratic formula. So x equals b squared minus, negative b, plus or minus b squared minus 4ac all over 2 times a. So negative 2 plus or minus 4 plus 4 is 8 over 2. The square root of 8 is 2 root 2. So if I reduce all that, I have negative 1 plus or minus root 2. Now I should check my answer. I need to check for an extraneous solution. Clearly that's not going to be extraneous though, since all the denominators before the zeros in the denominators would either be 1 or negative 1, and that ain't that. But that's the idea. Is that okay? Most of them, I think you don't have to do the quadratic formula. But if you can't factor it, or even if you just don't see how to factor it, like quadratic formula it up. The key step here is finding what to multiply both sides by. If you're able to do that and do the multiplication and reducing correctly, it's usually smooth sailing and nothing gets too complicated. If it feels like something's getting complicated, you're probably making a mistake at that step. And then the last one would be like an inequality one, right? So what if I have no, not yet. So nope, first thing I want to do is turn it into an equation. right? Now, the problem with getting rid of the fractions is I care not only about where this is equal to 0, but also where it's undefined, right? So I'm going to do my discontinuities right now. What do those discontinuities have to be? Three and negative 3. The things that can give me a 0 denominator, right? The things that would make it undefined. Yep. Now to do the zeros, then, we can multiply both sides of this by x minus 3 times x plus 3. So that's going to give me 2 times x plus 3 minus 4 times x minus 3 equal to 0. So 2x plus 6 minus 4x plus 12 equal to 0. So negative 2x is equal, plus 18 is equal to 0, or x equals 9. I waited to do that waited to multiply by this till I was doing the zeros because I care about the discontinuities. If I would have started there, would I have remembered to check for my discontinuities? Probably not, right? So I wanted to make sure I did that first before I went crazy with my solving. The other option would be to add the two fractions at the jump to make it one single fraction, then you can do zeros and discontinuity at the same time. But that felt like too much work for me. I think I'd prefer to do it this way.
Yeah.
Does that feel okay? All right, so I have everything I need now, so I'm going to draw my sign diagram. So maybe I'll pick negative 4, I'll pick 0, I'll pick 4, and I'll pick 10. Oh yeah, and I need to decide whether these are open or closed. So the discontinuities we know are always open. And the zeros will depend on if it's an or equal to inequality, which it is, so that should be filled. And now, because I didn't add the two fractions, this next part's going to be a little bit of a hassle that I think I'm going to use my calculator to kind of work my way around. So if I plug, let's give me my calculator here. So I have 4 of these things to plug in, right? Now, really, all I care about is where things are positive and negative. Ooh, boy, something's going on with my computer here. So what I'm going to do is I'm going to put this all into the y equals, and then I'm going to do y1 of the values, because I feel like it's just going to be easier than me trying to add fractions, which pass, and it'll be a little less time consuming than like me plugging in a new x every single time. So I'm just typing that original problem into the y1. And then I'm going to do y1 of negative 4. That's positive. And we'll do y1 of 0. That's negative. And we'll do y1 of 4. That's positive. And we'll do y1 of 10. And that's negative. So we had negative, negative, positive, negative, positive. Everybody's okay? So my answer, since I want less than or equal to 0, I want the negative parts. So negative 3 to 3 with parentheses, and then bracket 9 to positive infinity. And I get the bracket because of the filled circle and the parentheses because of the opens. But that would do her. What do you guys think on this? Is that feel any clearer as to like what to do for what these problems will look like or where you need to study? Does anybody want their half sheet back and go, ooh, I want to put something else on there? I have them up here. You can come and grab it. What do we have, like 25 minutes left or something in here?
Yeah.
Okay.
Yeah.
Why don't you just take the last 25 minutes to rejigger your half sheets or whatever, or run through another example, or talk to your neighbor about like, hey, what did he do here? I missed blah, 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 blah. But that feels like enough for a day, right?
Yeah.